So now that we've talked about pH, and pH is the power of hydronium, which relates to an acid, there's another scale, and it's less used because the pH scale will actually tell us about acids and bases. Below 7 is acidic, and above 7 is basic. But there's another scale that relates a little bit more specifically to bases, which is called the pOH scale. And the pOH scale has to do with the power of hydroxide. Remember, bases make hydroxide when they're placed in water, and hydroxide is the polyatomic ion, OH negative. And so when we talk about the power of hydroxide, we're talking about the exponent to which hydroxide is taken to when we're looking at its concentration molarity. For instance, if I have a concentration of hydroxide in solution at 1 times 10 to the negative 3 molar, this 3 would be the pOH. The pOH would be the power that the hydroxide concentration is. And in this case, the power of the hydroxide concentration is negative 3, but the pOH scale, as is the pH scale, is a positive scale. We just take the negative off and look at that exponent. So the pOH is 3. If the hydroxide concentration was 1 times 10 to the negative 6 molar, then the pOH would be equal to that power, which is 6. So the pOH would be 6. The pOH and the pH scale are intimately related because of the relationship we saw between hydroxide concentration and hydronium concentration. If you remember earlier, we said that the hydronium concentration times the hydroxide concentration is equal to 1 times 10 to the negative 14. Well, if you do some, if you take the logarithm of everything here, the negative logarithm of everything here, the negative logarithm of this side, hydronium times hydroxide, and you take the negative logarithm of the other side, 1 times 10 to the negative 14, and then you apply your logarithm rules. If you take the logarithm of two variables multiplied by each other, it's the same as the logarithm of the two individual variables added together. So plus the negative log of hydroxide equals the negative log of 1 times 10 to the negative 14. So all I did was take my equation that you saw in the first video and take the negative log of both sides. The negative log of hydronium, as we've talked about, is pH. And it turns out that the negative log of the hydroxide concentration is what we define as the pOH. So the negative log of hydroxide is pOH. And then if we do the negative log of 1 times 10 to the negative 14, we get 14. And so now we have our third and fourth equations that we're going to be looking at. pH plus pOH equal 14. And pOH equals the negative log of the hydroxide concentration. And so here is our last equation. pOH equals negative log of hydroxide. So now we have two more equations to work with and another scale. So let's look at how pOH and pH are related to one another and then do a couple of calculations. So how are all the variables that we've talked about related so far? Well, we said that pH and pOH have to add up to 14 always. So a neutral solution, which has a pH of 7, would also have a pOH of 7. And we said that a neutral solution has a hydronium concentration of 1 times 10 to the negative 7 molar and a hydroxide concentration of 1 times 10 to the negative 7 molar. Well, what if we start going into the acid range? Let's say we have a pH of 3. What would the pOH be? Remember, pOH and pH have to add up to 14. So the pOH must be 11. And if you do your calculation with your pH equation, you'll find out that the hydronium concentration is 1 times 10 to the negative 3 molar, and the hydroxide concentration will be 1 times 10 to the negative 11 molar. If we go into the base range, let's say that we had a base that had a pH of 10. Then the pOH and the pH have to add up to 14, so the pOH would be 4. The hydronium concentration would be 1 times 10 to the negative 4 molar. Oops, sorry about that. 1 times 10 to the negative 10 molar. And the hydroxide concentration would be 1 times 10 to the negative 4 molar. So notice that as the hydronium concentration goes up, the hydroxide concentration goes down, and vice versa. When the hydronium concentration goes down, the hydroxide concentration goes up. Same thing with pH. As the pH goes down, the pOH goes up, and as the pH goes up, the pOH goes down. So these are some relationships between all the variables that we've talked about. So let's do one calculation with all this, or one or two calculations, and then we'll call it a day. Let's say that you have a solution that has a pH of 9.6, and we want to know what is the pOH of this solution. So this is a very easy equation. We know that pH plus pOH is equal to 14. And if we substitute 9.6 in for the pH, and we keep our variable pOH and set that equal to 14, we can easily solve for the pOH by doing 14 minus 9.6. And when we do that, we get a pOH of 4.4. And so that's our pOH. And notice that with a pH of 9.6, we have a base, and a pOH that's low means that we have a base also. Low pOHs relate to bases, whereas high pHs relate to bases. So this is good. Well, let's try looking at this a little differently. Instead of calculating the pOH, what if I was given a pH of 9.6, same problem, but this time I want to calculate the hydroxide concentration. Well, I haven't given you an equation that goes directly from pH to hydroxide, but I have given you an equation that goes from pOH to hydroxide. It's pOH equals the negative log of the hydroxide concentration. So if this was your problem, you would first have to calculate your pOH. You'd have to go from pH to pOH, and then you could go from pOH to your OH concentration. So if you remember from our last problem just a second ago, for a pH of 9.6, the pOH is 4.4. So we can plug that in to our problem here. So we plug in our 4.4 for the pOH, and that's the negative log of the hydroxide concentration. If we take the negative to the other side and raise both sides, take the negative to the other side, that makes this negative and this positive. And then if we raise both sides to the power, 10 to the power of each side, we get 10 to the negative 4.4 power equals the concentration of hydroxide using our logarithm rules. And so 10 to the negative 4.4 power will give us our hydroxide concentration. When you do that on your calculator, you end up with a hydroxide concentration of 3.98 times 10 to the negative 5. And our unit for concentration is molar. So here is our final answer. So sometimes you have to do multiple steps. In this case, I had to convert pH to pOH first, which I'd done in a previous step. Then I could substitute pOH and solve for OH concentration. So that's it. 4 equations, 4 variables, and multiple ways to solve these problems. So try working out your homework, and good luck.